When ambient summer temperatures spike past 35 degrees Celsius, your hydraulic system is running on borrowed time. High oil temperatures destroy seals, reduce fluid viscosity, accelerate pump wear, and cause unexpected shutdowns. In this video, we are breaking down why hydraulic oil overheats in summer and the exact circuits adjustment protect your machinery. So stay with us until the end of this demonstration. Hydraulic heat isn't just caused by ambient weather. Heat is generated whenever fluid flows from high pressure to low pressure without doing mechanical work. Every bar of pressure dropped across a relief valve or throttle converts directly into heat energy. In summer, because the reservoir can no longer radiate heat naturally into the warm surrounding air, that heat accumulates, triggering a rapid rise in oil temperature. To maintain safe operating temperatures, you rely on faucet cooling, air-cooled exchangers, use electric or hydraulic fans, and are ideal for mobile machinery and remote plant locations. However, their cooling capacity drops as ambient air temperatures rise. Shell and tube water coolers provide consistent thermal control regardless of air temperatures, but they require a clean water supply and regular descaling maintenance. Placement matters just as much as cooler size. Placing a cooler directly in the main return line exposes it to high pressure spikes, which can rupture the cooler matrix. The gold standard for industrial systems is an offline kidney loop. By using a separate dedicated low-pressure pump, you ensure constant, low-velocity oil flow through the cooler and filter 100% of the time, independent of main machine operation. Before summer production reaches full peak, perform these 4 critical checks. First, clean cooler fins with compressed air to remove dust and oil residue. Second, checks oil levels. A low tank volume reduces settling time and heat dissipation. Third, verify that system relief valves aren't dumping unnecessary oil back to tank. And fourth, test thermostatic bypass valves to ensure fluid actually route the cooler when temperatures reach 45 degrees Celsius. Preventing hydraulic overheating comes down to smart sequence design and proactive summer checks. If you found this breakdown helpful, hit the like button and subscribe to the channel for more practical fluid power and automation guides. Drop your thermal troubleshooting questions in the comments below, and I'll see you in the next video.